Okay, good morning. So this is the last part of this lesson, number theory. So, uh, and this is a simple lesson. I don't know how many of you have seen numbers in different bases. So have you heard about binary system or something like that when you are coding or something? This is more or less that lesson. So you know that probably because we have 10 fingers, the base of our counting is 10. For example, when you write 1, 2, 3, what do you 123? What do actually you mean? For example, if you say that I have 123 pens or whatever, what does it mean? Yes.
You have 12 tens and 3.
Yes, a little bit more explicit, but that's right. You have 12 tens and 1 3. Okay, but if I want to make it explicit, I would say that I have 3. Let me write it like this. I have 1 in which I have 100, okay? And then I have 2 packages of pens in which I have 10 pens, and then 3, okay? So when you say 123, actually you mean 1 times 100 plus 2 times 10 plus 3, yes? Is that clear? So that's what you say. You can write it as powers of 10, okay? So you can write this to the power of 2, 2 times 10 to the power of 1. But of course here you can also write 10 to the power of 0, but 10 to the power of 0 is just 1. We keep it. So this is called the units digit, yes? And this is called the 10th with S digits. And then this is called hundredth. I don't know even how to hundredth with S. Okay. Okay, it seems reasonable. So we have 10 fingers, so we actually put the base of our counting the number 10. Yes. But of course, you understand that there is nothing very specific about choosing this 10. In principle, you can choose any other number that you like for this counting. Yes. For example, let us choose, for example, 3. Yeah. Here, the base of my counting is number 10, which appears here. If you want, I can give you more examples. So when I say 4,572, what does it mean? It means that 4,000 plus 500 plus 70 plus 2. But 4,000 can be written as 4 times 1,000. 1,000 is which power of 10 is the third power. Yes, and the next one is 5 times 100, but 500 is what? 10 to the power of 2. And this 70 means 7 times 10 to the power 1, which we don't write, and then plus 2. Okay, and what happens if I have zeros in between? For example, 200, so let me write 2002. Okay, so what does this mean? This means 2000, which is 2 times 10 to the power of 3, and then 0, 10 to the power of 2, and then the next one, 0 times 10 to the power of 1, and then plus 2. Of course, you can just drop them, but this is the way that you expand. For example, if I write this number, 5 times 10 to the power of 4 plus 3 times 10 to the power of 2 plus 1. If I ask you, what is this number? It is very simple for you, of course. You can say that this is 10,000, I multiplied by 5, this is 100, I multiplied by 3, and this is 1, then I add them up. But if you want to see that, you can immediately write the answer. So this is your units digit, yes? The next one is supposed to be which power of 10? 1. But the first power of 10 is absent. So it means its coefficient should be 0. So the second digit should be 0. And then the next digit is what? The second power of 10. The coefficient is 3. And the next one is 0 again, because you expect to have the third power of 10. It is absent, so that should also be 0. And finally, the last digit is 5. Of course, it is very simple, okay? If you don't believe that, raise it to power 4, it becomes 10,000. You multiply it by 4, it becomes 50,000. this becomes 300, and this becomes 1. So that's 50,301. Okay? So you should be able to go back and forth. Okay? If you want to have a good understanding of this topic. Of course, very simple. But let us start with this simple number because I want to be able to do it in my head. So let us start with this simple number 123. And instead of focusing on 10 as my base of counting, let me focus, for example, on 3. Okay, so let us choose the base. So here, let me write B for the base. The standard base that we always work is base 10, but let us now, for example, choose base to be 3. Yes? Okay, so it means that I need to work with powers of 3 rather than powers of 10. Okay, so it doesn't hurt if I have a list of powers of 3 here so that I can use them. So the first 3 to power 1 is just 3, 3 to power 2 is 9, 3 to the power of 3 is what? 27. 3 to the power of 4 is 81, and 3 to the power of 5 becomes 3 times this, it is 243, which is already above the number that I'm working, so I don't really need to continue. Okay? So I will start. I would say that what is the biggest power of 3 that I can fit into 123? So you see the list. What is the biggest number that you can fit there? It is 81. Yes, which is the 4th power of 3. Okay? So can I fit one of them there? No, because this is 243. I have only 123, yes? So I cannot fit any one of them, even one of them inside that, okay? But I can fit this one there. How many of them you can fit there? You have 81. How many 81s, how many complete 81s you can fit in 123? 1. So what you write? You write 123 is equal to 1 times 3 to the power of 4. Okay? You can fit only 1 3 to the power 4 inside 123. But that is not it, because there are some remainders, something left for you. Yes? Okay, so you just do the calculation here. Your original number is 123. How many of them you have used so far? 1 times 81, which is 81. So you subtract 81 from that. So it is 2 and 4. You agree with me? So 42 is left. Then you ask yourself, now how many powers, which is the highest power of 3 that I can fit in 42?
Third power.
Third power. But how many of the third powers you can fit? Again 1, yes? Do you agree with me? So I can only add 1 of them. Okay, so it means that I calculated 27 again. So I have to take 27 out from it. So how many is left? 15. I'm subtracting, yes? Okay, and then the same question. What is the maximum power of 3 that I can fit in 15? Of course it is 9, yes? So what I should do, how many 9s I can fit here? 1 again. So this becomes plus 1 times 3 to power 2. 3 to power 2 means 9, so I take 9 out of it. So what is left? 6. Okay. Again, the same question. What is the maximum power of 3 that I can fit here? 3 to power 1. Okay? So 3 to power 1. But how many of them I can fit? 2 of them. Do you agree? So first of all, let me know. Are you coming with me? Or is that understandable? Okay. And then, is there anything left? No. Okay. Okay. Anything left means what? So it means, do you remember? Because the units digits should also be written. Okay. So the units digit doesn't have this power of 10. In this case, we shouldn't have any powers of 3. So if you stop here, I want you to understand, you need to write 0 at the end because nothing is left. Okay, so the units digit is actually 0. So now if I ask you to write this number as if 3 is playing the role of 10, what do you write? In this case, you start from the left hand side, the highest power, the digit is 4, and then is 5, then is 7, then is 2. Okay, so you do the same thing here now. So what is this one? 1. The next one is 1. So, but be careful, these are consecutive powers. If you are skipping one of them, the coefficient is 0. So you have to consider that. So 1, 1, 1, 2, and 0. So this number, 123, if you want to emphasize, this is in which base? Base 10. In your book, they write it like this. I prefer to put a pair of brackets. They put the 10, or in words, they write 10. Okay, something like that. Okay, but let us use this one. So when I write this, whenever the base is 10, either I don't write it or I emphasize it like this. This is just the normal 123. But if you have so many pens in your hand, and if you change the base of counting from 10 to 3, that number now is represented by this number, 1, 1, 1, 2, 0. This is base 3. Is that clear? Well, that is the change of basis idea. So I am going from base 10 to base 3. So how many digits you see here in my number? 3. But how many digits you see? 1, 2, 3, 4, and 5. So this 3-digit number, which was a 3-digit number in base 10, if you represent it in base 3, it becomes a 5-digit number. Okay? So this is the idea of going from one base 10, to another base. Yes?
If we were to use base 3 as our normal counting system, would we have 3 as a number? Or would 3
No, that's a good question. You see here, that's a good question that you ask. Here, when I have 10, what is the maximum digit that can appear? 9. So it starts from 0 up to 9. And this is already clear that this will not happen. If you work in base 3, what are the digits you expect? 0, 1, and 2 maximally. Okay, because if that is not the case, if 3 appears here, it means that you have miscalculated in the previous step. Yes, you didn't put the maximum power there. So this is why something bigger than 3 is left. Okay, so this is why this does not happen. If I have base 4, what digits you expect? 0, 1, 2, up to 3. In general, if I work with base B, any B, so what are the digits are allowed? 0, 1, 2, 3, up to less than B, which is B minus 1. Okay, so the digits, if you work in this base B, the digits that are allowed are actually these digits, allowed digits, yes? In base B. Okay, so that's good to know. But the conversion should be both ways. Sometimes in the exercises in the book, a number in base 10 is given. You're supposed to switch it to another demanded basis. Sometimes in another basis is given, you have to switch back to the base 10. Okay, switching back to the base 10 is also simple. So let us say that I give you this number, you don't know about 123, and I ask you to reverse the calculation and go from base 3 to base 10. What do? Just expand, yes? I would start from here, 0, and then 2. What is the meaning of 2 here? 2 means 2 times 3 to the power of 1. Yes? The next one is 1, so I write 1 multiplied by 2 to the power 2. The next one, 1 times 3 to the power of 3. The next one is 1 times 3 to the power of 4. So when you see this is nothing except this. So if you are confused about the basis, remember, if you open it up, this is exactly what you are used to. Okay, this number that you get. So we calculate. So this becomes 81, this becomes 27, this becomes 9, this becomes 6. And if you add them up, you will see that the number becomes 123. So is that right? Okay, so switching back and forth. Of course, I will give you more examples. But this is the idea of working in different bases. For example, in computer science, which base is very common? The binary basis, yes? So either you have 0 or 1. If you are working in a binary system, it means that the base is 2. And if the base is 2, the digits that are allowed are 0 and 1 maximally. So this is why you always have 0s and 1s if you are working in the binary system. Okay, we can, for example, for practice, let us try to answer this question 123 in base 2 as well, okay? Okay, let us review everything from scratch once more. So you want to write 123 in base 2 this time. Okay, so the question is that if I give you 123, which is the normal number that everyone knows, and ask you what will be this number if I switch to base 2. Okay, so what should I do? Instead of having a list of powers of 3, this time I need a list of powers of 2. Yes, so this becomes 2, 1 is 2, 2 to the power of 2, 4, 3 is 8, 2 to the power of 4 is 16. So 2 to the, you have to consider until you go beyond this number. Yes, 2 to the power of 5, 32, 2 to the power of what, 6, 64, 2 to the power of 7, 128. That's enough because I already go beyond that 123. So what should you do? So you write 123 in base 10 is equal. So let me get it right. Okay, so I want to switch it to base 3. So what should to base 2? What is, you need to ask yourself, what is the maximum power of 2 that I can fit into 123? 2 to the 64, which is 2 to the power 60, 2 to the power 6. How many of them I can fit? 1. So you just need to write 1 times 2 to the power 6. Okay, and it is also good to have 120 here, 123 here. So 1 times 2 to the power 6 is 64. So 64 of it is gone. What is left? So this is 9, and this is what? Is it 5? Yes. Yes, that's right. Okay, now the same question. What is the maximum power of 2 that I can fit in 59? The fifth power. Okay, how many of them I can fit? Again, 1. So I would write 1 times 2 to the power of 5. But 32 should be subtracted here. So what is left? 727, yes? Okay? And then I would ask the same question. What is the maximum power of 2 I can fit here? This is the maximum power. How many of them I can fit exactly? 1 again. So I subtract 16 from here. What is left? 11. So what's the maximum power I can fit in 11? The power of 3. How many of them I can fit? Only 1. Okay? So 8 is also subtracted. What is left? 3. So what is the maximum power of 2 that I can fit in 3? 2 to the power of 1. Okay? So how many of them I can fit? 1. So I have to write plus 1 to the power of 1. But you see that now it is not consecutive. Yes? It was 6, 5, 4, 3 in order, but suddenly I had to jump to 1. So it means that what is left in the middle? 0 times 2 to the power of 2. There are no 2 to the power of 2 I can fit. I have to jump to the 2 to the power of 1. So, but instead in writing this, you have to consider this because this will play the role of 1 digit in this case. Okay? Okay, and then, sorry for the mess a little bit. So I have put 2 here. What is left? 1. So I add 1 at the end. Okay? So this is the way that I have to expand 123 in the base 2. And then I have to write the digits. 1, 1, 1, and 1. So be careful. If you hadn't written this one, then you jump to 1, 1. But that is not correct. You have to write 0 because of that, jump, and then 1, and then 1. Okay? So that is your number if you go to base 2. Okay? So let us do this with GeoGebra also, because I want you to know that. So as usual, I prefer not to have I go to cast view, but let us get rid of the other views not to be disturbed. So I just take off the graphic one. So remember, so you need to know how to do it in both ways. If you want to go from base 10 to another base, so the command is to base. Yes, do you see that? It's very small. Okay, so you write 2 with capital T and to base. Okay, and then what you press enter. Then you see that the instructions are there. So I put my number. So what was my number? For example, in this case, it was 123. So let us check both of them. There I went to base 3. Okay, so I just go and choose base 3 and let us see what happens. So this is the way that GeoGebra writes 11120 in base 3. So that's exactly the number we got there. And if I want to go to base 2, so I would write 2 base again. So the number is 123 again, and now the base is what? 2. Let us check that one as well. So it includes 1, 1, 1, 1, 0, 1, 1, 2. Yes, that's correct. But now you have to remember this. If you want to switch back, okay, that is called from base. Okay, so you write from base. You see from base, but you see that it is mentioned number as text. Text in GeoGebra means inside quotation marks. Okay, so if you want to switch back, let us pretend that we don't know. For example, let us take this one, and I want to switch back this number to base 10. So I use the syntax from base, and I type this number 11120 in quotation marks. So I put a quotation mark, and then I put 11120. Is that right? That is that number? Okay. And then I go and choose my base. What was my base? It was 3. I want to switch back to 10. If I haven't done something wrong, I should get 123 back. So this is the way that you go back and forth. Yes? So 2 base takes you from 2, takes you from 10 to any other base. You shouldn't be worried about typing. But if you want to switch from another base to base 10, you have to put your number in quotation mark. So you have to prove it an integer. So we'll see probably why. Okay. So let us now go back to the board. So you see that there is no limitation for this b. Okay. For example, I can choose b to be even greater than 10. Okay. For example, this is a little bit counterintuitive, but it works. So for example, we worked with base 10, 2, and 3 here. So let us, for example, choose my base to be, for example, 12. Then what will, yes?
Can the base be bigger than the number itself?
What do you mean?
I mean, like 123 written as base 124. That's the possible, or is it?
No, in principle you can. You can have 1, 2, 3 in base 124. Yes. Yes. So base can be any number. Yes. From so the base, of course, is not 1. We don't have base 1. The base should be a number starting from 2 onwards. Okay. But there's no limitation in principle. Okay. So if I have b equals to 12, what is my problem here? Yes.
You don't have. You have to.
Because if I decide to work in base 123, so what are the allowed digits now? If I want to work in base 12, what are the allowed digits? The allowed digits starts from 0, 1, 2, 3, up to b minus 1. So the digits are 0, 1, 2, 3, and then you continue this list. You write to 9, and then of course you shouldn't stop because I have to go up to b minus 1. So the next number is 10, and the next number is what? 11, then I stop. So this is a little bit confusing because 10 itself is also 1 digit now, and 11 is also 1 digit. Okay, then it becomes a problem. So for example, if I write 123, so let me write it 113. So it is not correct to read it 113 because the way that we read numbers is just base 10. So let us read it 113, and then I put base 12 here. Okay, so it might happen that 1, 1, and 3 are 3 digits because 1 is allowed, 3 is also allowed. So 113 is actually a very well-defined number even if you are working in base 12. But might be 11 as a whole is supposed to be considered as 1 single digit. Okay, so then if we don't have any conventions, we don't know. Is it 11 as 1 digit and then 3 or 113? Because if you consider it 113, then how many digits are there? 3. But if you consider it 11 as 1 single digit and 3, then how many digits are there? 2. Okay, so this, because of this confusion, this is the trick that we use in mathematics. So we put letters instead of these digits. For example, this is according to the English alphabet. So this is given capital A, this is given capital B. So if you see 113 in base 12, it really means 113. If you mean 11 and 3, then you have to write it B3. 12. Okay, so these are not the same thing. So whenever you see this number in base 12, it is really three-digit numbers, a three-digit number, 113. But if you mean this is one digit, then you cannot write this and say, I mean this. No, you have to write B there. Okay? Is that clear? Okay, so let me test your understanding. If I ask you what this number is, because base 12 is not something familiar for our brain, if I ask you this, give me this many pens, how many pens do you give me at the end? So you need to switch to base 10. But how do you switch to base 10? Can you tell me? So 1, 1, 3, base 12. I want to write it as base 10. So how should I write that?
3 times 12 power 1 plus.
No, 3 is the units digit. So the units digit doesn't have any base to power or something. Yeah, so I will start from this one. 1, 1, 3, 12. What do I write? 3. Okay, so if you want, yes, let us write 3 here. But the next one is which digit? 1 multiplied by which power of what? 12 to power 1. Yes, because my base is 12. This is the units digit, and this is the next digit. Yes, so that's 1. And then plus what?
1.
Again, this digit multiplied by 12 to power 2. Is that understandable? So, okay, then you have to calculate this. So this number is 144, this number is just 12, and this number is 3, and you add them up, it comes 159. So if I ask you give me this many pens, it means that you have to give me 159 pens as the normal sense. Okay, so let us also check this with GeoGebra. So which one I have to use? If I want to calculate this number, I have to use from base or to base? From base, because this is a base other than 10. So I have to write from base. Okay, so what is my number? 113. Oops, I have to put it in quotation marks, yes. Okay, and then base. What is base? 12. And that's 159. So that's the number that we got here. Okay, but let us do this one as well. Okay, so let us go back to the board. Okay, so what about this one? Can you tell me if I ask you this many pens, what is the number here?
3.
How many digits are there? There are 2. Okay, so I have to write 3 plus the next digit, which is B, multiplied by 12 to the power of 1. Okay? Is that right? That's the same expansion. But if I ask you what B is 11 multiplied by 12 and then plus 3. And then you calculate this number. Yes?
Is B always 11?
Yes, this is a standard. So even if you go to higher bases, if you go to base 13, you will have another digit here which is called 12, but this is still A, this is B, the next one is C. That was a good question, thank you. Yes?
What two digits to base as 3 digits?
What? Repeat it, please.
Sorry, B for example is 112.
B is 102. Okay, in that case we are in trouble. So then you probably have to invent another. It might be in that case Chinese alphabet is better. Yes, then we can go to higher heights. Okay, but anyway, so you calculate this one 11 times. This one is 100, so 135 in total. Yes. So this means that this number, which is a little bit unusual for us, this is the common number 135. So let us check that one as well. So you write from base. So you know that you have to put the quotation mark because you really include the text. So I put my quotation mark, I put capital B, and then after capital B I put 3, but my base is 12. Okay? Oops. So, yes, that's correct. 135. Yes? So this is the way that you can actually go back and forth between different bases. So what about if I want to go from a base which is not 10 to another base which is also not 10? Do you have any idea? For example, I give you a number in base 3, I ask you to switch to a number to base 8, for example, going from base 3 to base 8. What comes to mind first? The very simple idea. What do you think you will do? Yes?
First, take the base to base 10, and then from base 10.
Yes. That's the idea, usually, okay? So, for example, if I ask you to go from base 3, if I ask you to go from base 3 to base 8, what you do, you go to base 10, and then from base 10, you go to base 3. Okay, well, that is what we do normally. Okay, so let me give you some examples. Let me see. Okay, so let us do this. It is a little bit lengthy calculation, but let us do it. It doesn't hurt. Okay, so but there are some cases that there are some exceptions. By this I will solve this problem in two different ways. This is the standard way. If you want to go from a base which is not 10 to another base which is not 10, usually I would say most of the time you have to switch to base 10 and come back to the base 1. But now I give you an example that we can solve it in two different ways. Hopefully I can do it in my head here on the board. So the number is 101. How many ones are there? 4 ones, 3 zeros, and 1. I also have another 1 there. So this is base 2. My question is that what is this number in base 8? Okay. So we can do that, okay? Let us just do it here on the board. So the first thing I do, according to what I told you, this is base 2, we want to go to base 8. So I switch to base 10, and when I found my number in base 10, I go back to base 8. Okay, so here my base is 2. I go to base 10, and then I go to base 8. Okay, so how should I go to base 10? I think it should be simple for you. Yes, 1, 0, and then 4 ones, 3 zeros, 1, 0. Okay, base 2. What is this one? If you don't mind, let me start from the left-hand side. It is easier. I will take this number, okay? And then the next one is 1, but multiplied by 2 to the power of 1. And then the next one is 0, multiplied by 2 to the power of 2. I increase the powers of 2 one by one. But be careful. For simplicity, I am writing from right to left, okay? And then I go here. What is that? I increase the power. I go here. I increase the power. I go here. I increase the power. 1. Yes. Another 1. Yes. Another 1. Yes. And then 0. And then, am I right or not? So let me count the digits. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So that's right. So if you have 11 digits, the maximum power should be what? 10. It's always 1 less. So let me see. 0, 1, 0, 0, 0, 4 ones, and 0 and 1. Yes? So then I have to expand this number. So what happens here? So let us calculate. Hopefully we can do that. This is 0, so I ignore 0. So this is just 2. This is 0, 0. This is 32. This is 64. This is 128. This is 256. And this is 0. This is 1024. Yes? Okay, so let me add them. This one added to this one, 160, 220. Okay, so this one and this one, 160, 224, 226, 226, 256. What is that? It's 12, 8 of 4. Okay, and then I add it here, so this becomes 6, 0, and then 5. So 1506. So that is my number. Let us also check, because this is a little bit boring calculation. So I should write from base. So what was my number? I have to put it in quotation mark. I have 1 0 1 1 1 1, and then I have 3 zeros and 1 and then 0. So that's my base 2. Yes, that's correct. The calculation is correct. So I got 1506, and now I want to switch back to base 8. So do you remember what I'm supposed to do? Yes, what should I do now? I need powers of 8. Yes, it's a little bit boring, but let us see how much we can do. 8 to power 1 is 8. 8 to power 2 is 64. 8 to power 3? 8 to power 3 means 2 to power 9, so I remember it. It's 512. And then another 8 we don't need. Yes, because 8 to power 4 will be 8 times this one, which I will go beyond this number. Okay? So now I want to switch back to base 8. So I would do this. I will ask myself, what is the maximum power of 8 that I can fit here? What's the maximum power of 8? The third power. How many of them I can fit here? It is clear I cannot fit 3 of them, because 3 of them will go beyond this. So I have to fit 2 of them. So 2 of them. So 2 times what? 8 to the power of 3. But again, you write it here, for example, and then you start. 2 times this, how much is that? 1024. So 1024 is gone. So if you subtract them, how much is that? It is 2, it is 8, and it is 4. That's it. 482. So what is the maximum power of 8 that I can fit in 482? 64. How many of them it fits, do you think? 7, not 8. 7 fits? Yes, it seems to. Yes, let us check. So if I multiply 640 by 7, you can use your calculator, of course. 28. Yes, that's correct. So what is the answer? It's 448. So I take 448 out. So what is left? Is 4, yes, and then 5, 3, and 0. 34. Okay? So now what is the highest power of 8 that I can fit there? 8 to power 1. How many of them fits? How many of these 8s I can fit in 34? 4 of them, but what is left? 2 is left. Yes? So then I write my digits. So this becomes what number? 2, 7, 4, 2, base 8. So the question mark that you are supposed to fill in is this number. Yes? 2, 7, 4, 2. Okay? Okay, let us also check that one, because I want to make sure. So how should I check it using GeoGebra? So I have to go to base, or this is also, yes, 2 base, because I want to write 2 base from 1506 to base 8. 2, 7, 4, 2, 8, yes? So 2, 7, 4, 2, base 8. So that was correct. Okay, but do you see that this is an exception? Might be you can find a shortcut a little bit here, because these 2 and 8 are connected with powers. 8 is 2 to the power of 3. Whenever these bases that are given to you are somehow related together with some kind of powers, then might be you can find an alternative. Okay, so let us double check that. So this is an exception. Okay, so this is the standard way of doing this problem. But in this case, these 2 bases are related with powers. 8 is 2 to power 3. Whenever this happens, you might be able to find an alternative way. Okay, so because when you write this down, you have powers of 2, but your goal is to have powers of 8. And because 8 and 2 are related with powers, might be we can find a shortcut. Okay? So let us try to understand this one. Okay, so let me clean this. We don't need it anymore. And then start doing that part. Okay, can you tell me how to arrange? Because first of all, if you don't mind, let me just take these off, which we don't need. These are actually zeros. So what is left for me is just 2 to the power of 1 multiplied by 1 plus, then I have 2 to the power of 5 multiplied by 1, 2 to the power of 6, and then plus 1 times 2 to the power of 7, and then plus 1 times 2 to the power of 8, then 1 times 2 to the power of 10 suddenly, yes? So this is arranged in powers of 2. Your goal, if possible, is to arrange this as powers of 8. So can you do that? For example, let us start with the biggest one. How can you write 2 to power 10 as some power of 8? Remember, 8 is 2 to power 3. Yes, so what can I write for 2 to power 10? Yeah, so in principle, it means that 2 to the power of 10 is 2 to the power of 3, to the power of 3, which is 2 to power 9 so far, but with 1 2 extra. Yes? Is that right? 2 to power 10 is 2 to power 3 to the power of 3, and then multiplied by 2, because 2 to the power of 3 to the power of 3 is 2 to the power 9, and then you multiply it by 2, it becomes 2 to the power of 10. And then 2 to the power of 3 is nothing except 8. So this is 2 times 8 to power 3. So yes, I was able to write this as 2 times 8 to power 3. Okay? What about this one? Do you have any idea for this one? Again, 2 to power 8. Help me to write it. So what is... The base is 2 to power 3. I have to start from here. But raise it to which power? 2. So far, how many of them I have? 6, yes? And how many is left? 2. So it is 2 to the power of 2. How can I write it down? This one is 8 to power 2. This one is 4. So it is 4 times 8 to power 2. Yes? So this number is 4 times 8 to power 2. Do you agree? What about 2 to power 7? So if you do the calculations in your head, it is easier, but let us just do it here. So 2 to power 7. I would write 2 to power 3. This is my starting point. To which power? 2. How many is left? 2, no, 1. Because 2 times 3 is 6, it is 7. So 1 is left. So this becomes 2, 8 to power 2. Yes? Okay, and what about this one? This is very simple. 2 to power 6 is just 2 to power 3 to power 2. So it's 8 to power 2. So you see, we have to combine them because we should not have 8 to power 2 in 2 places. But we can do that later. So what can I do here? 2 to power 3. Yes? 2 to power 2 times 2 to power 3 is 2 to power 5. But 2 to power 3 is 8, this is 4. So this becomes 4 times 8. Do you agree? And should I do something here? No, that's just simply... Yes? But be careful. How many... You see 8 to power 2 appears here and there. In the expansion of a base, you have to have each power in one location only. So what does it mean? It means that you have to combine all these powers of 8. So what is the answer? Can you tell me? 7. Why? Because you have one of them, you now have 2 more of them, and then now you have 4 of them. So how many of 8 to power 2s you have? 7. So this can be written as 7, 8 to power 2. Okay, so let me write it in order now. So 2 times 8 to power 3 is the first one. I combine all of them together, so it's 7 times 8 to power 2, 4 times 8 to power 1, and finally 2. If I insist you to write this in base 8, what are the digits? This 2 is the first digit on the left, this is the next digit, this is the next digit, and that is the next digit. So this is the number in base 8. And that's exactly the answer we got there. Okay, but this method only works if the bases given are somehow related as a power. Otherwise, it doesn't work. So you have to go to 10 and 10 back to that. Is that clear? Okay. So if you don't mind, let me also solve another problem for you. So can you do this for me? So can you write number 3000? You can use your calculator if you want to. So 3041. I want you to write this number. This number is in base 10. Let me emphasize it. I want you to write this number in base 16. Okay, so what are the allowed digits? 0, 1, 2, 3, up to 15. And then you know the letters. 10 is for, A is for 10, B is for 11, and you just continue. And I can write the powers here if you want to. So can you see? It shouldn't be hard, yes? So 16 to power 1 is what? 16. 16 to power 2 is 256. And I really don't, do I need 16 to power 3? No, because 16, if I multiply this once more by 16, it goes beyond that. So it's good. You just only need these two numbers, okay? Yeah, do that because you need to learn this. I will give you more interesting examples, of course, but this is the standard way that you need to know. Okay, could you do that? Yes? Yes. Did it work? Because these numbers are not that easy. I think it is better to use your calculator unless you are good in calculating by hand, okay? I will wait a little bit more. Okay, could you find the answer? What is that? BE1. If you don't mind, because I don't know the answer, let us check it with GeoGebra first. BB1 you said, yes?
E1.
BE1. What about the others? The same answer? BE1? Okay, so it's good, probably. So I need to go from base or to base. To base, yes. To base. The number is what? 3041, and the base is supposed to be 16. Yes? Yes, so BE1. That's correct. But let us, if some of you doesn't understand how, let me just do it on the board. So what we are supposed to do, we need to divide. So if I need to ask myself, what is the biggest power of 16 I can fit here? It's clear, it is 16 to power 2, but that is 256. How many 256 you found that I can fit in this? 11? Did you check that? Okay. So because I know that you know your answer is correct. So it means that this is this one. Yes, and I think it's right because 10 of them gives me 2,560. One more, it is still below this, but next more will go beyond that. So that's correct. 11 of them. But how many of them are left? So I have to calculate. So this is 3041. I multiply this by 11. So this one. Yes, so this is 61182. Yes, so 2,860. I subtract. So I multiply this by my calculator, for example, and I subtract it. It becomes what? 5, 2, and then this is also 2, and sorry, is that right? That's it, yes? 225. So that is my leftover. Then I ask, what is the highest power of 16 that I can fit in? Just 16 to power 1. But how many of them? What was that? 14? Okay, so 14 times 16 to power 1. Do I have any leftovers? Because it is just 1 left, yes? And then 256 is 16 to power 2. Is that right? Okay, and if you write the digits, 10 is which letter? A11 is, B12 is, C, okay, and I need 14 as well. So 13 is D, 14, as you said, is E. So yes, 11 is the first digit from the left, which is B. 14 is the middle one, which is E. And 1 is just simply 1. That is just base 60. Yes? Is that understandable? Okay. But there are other type of problems. Let us try to give you some examples of those types as well. I don't know which one we start with. For example, this is a good example, I think. So this switching back and forth is actually level 1 problem, or sometimes might be level 2. But if you want to see what are level 3 problems, these are the types of problems, yes? So, example. In which base B do we have this relation? It is 4, 4 base B to power 2 is equal to 1, 0, 1, 0 base B. Okay, so this is a little bit higher level questions, and it is more interesting because these kinds of things are just calculations, multiplying things. Okay, so the question is that in which base, okay, 4, 4 to power 2 becomes 1, 0, 1, 0. Okay, this is, we want to answer the question. But for example, before even starting, I'm just trying to test your understanding. Do you think that B can be, for example, 3? Why not? Because 4 is used, yes? If B is 3, the maximum digit which is allowed is 2. But you already see that B is, so this 4 is appearing. So what is the minimum value for B? 5. It is clear that B cannot be below 5, yes? But what we don't know exactly. So we want to calculate this. So how should I calculate this, do you think? The base is very simple. You just expand. Okay, so this is the simplest idea. Whenever you want to find questions regarding the bases, because working in different bases is not that easy for us, we always expand, and it hopefully will work. Okay, so let us do that. If I ask you what is the meaning of this, you say that this is 4, 4 in base B. If you expand this, what do you write? 4 is your unit digit, and then the next digit is 4, and then you multiply by what? B to power 1, which is just simply B. So 4, 4 in base B, if you want to express it in base 10, this is your number in base 10. Yes? And then this to the power of 2 is supposed to be equal to this number to the same base. So then you expand this again. So how should I expand? From the right to left. So this is 0 plus 1 times, let me emphasize here, 1 times B plus 0 B to power 2. And finally, 1 times B to power. So it's just very simple. So you just immediately translate your problem from a base B problem to a just normal equations that you are working. And then you have to solve this equation, of course. Okay, so let us see if we can solve that. Might be that was not a very good example because this is a third degree equation. Let us see if we can solve it. So then I raise it to power 2. What can I do? Okay, let us just do it a little, because you know that if I raise it to power 2, it becomes a second degree equation. But what is my equation? It is third degree equation. Third degree equations are not easy to solve at all unless we can factorize them. Okay? Okay, so let us see if we can factorize them. Here I can pull a 4 out. It becomes what? To the power of 2. Here this is gone and this is also gone. B and B cubed are left. Can I factorize it? Yes, but that's unfortunately not helping, yes? Because b, if I factor it out, it becomes 1 plus b squared. Okay. So might be that was not a good example. Because let us see if we can solve it. So if I raise it to power 2, it becomes 16. This one to power 2 is 1 plus 2b plus b squared. And then unfortunately, because I couldn't simplify it, let us multiply it back. That was nothing. So, and then I have 16b squared plus 32b's, and then plus 16 is equal to b plus b cubed. No, solving this is not. We will study solving these in the very last chapter of this course, of Math 4 course, but not now, okay? So this becomes b to the power of 3, and then I move that, it becomes minus 31b, and let us move it to the other side, and minus 16b squared, and minus 31b, and then minus 16 is equal to 0. Okay. So it is not that easy to solve this equation with the methods that you know so far. But for example, let us say that I have allowed for you to use GeoGebra. Okay? So I give you this question in the exam and the GeoGebra is allowed. GeoGebra will not be able to reach this equation. So you need to reach this equation yourself and then try to solve it using GeoGebra. Okay? But let me double check my calculations. So this is 16b squared, 32, 16, b plus b cubed. So I move these to the other side, b minus 16b squared, minus 31, minus 16. Apparently it seems to be right. Okay, so let us go back to GeoGebra. It's also good to know how to solve these problems using GeoGebra. So hopefully you know. So what should I do? Which syntax I should use in GeoGebra? Solve. Yes, I write solve. And then, by the way, GeoGebra is good in solving equations in X. Okay, if you want to solve it in another variable, in this case b, let us just do this with b. So I would write b to the power of 3, and then I would have minus 16 b to the power of 2, and then I have minus 31b, and that one is minus 16 equals to 0. Yes? And then what is my variable? B. Let us see if it works. It doesn't work. So it means that I have done some wrong calculations. Do you see my mistake somewhere? Because this is not acceptable, yes? Why is that?
There should be multiple.
Yeah, B should be a whole number, so it doesn't matter. So it might be I have done some mistake somewhere, or I have written it wrong. So let me see. No, I think I have written it correctly, but so let us double check my calculations there. So either there was a misprint, I didn't know about that. So do you see any mistake in my calculations? So 4b is 4b is 4 plus 4b. That's correct. And then this is 0, 1b, 0b squared, 1b cubed. That's also correct. Then I raise it to power 2, it becomes 16. Yes? And this one to power 2, 2 times the first one times the second one to power 2. That's also correct. And then I multiply this b there. So, then I multiply this in 16b squared. 16 times 2b is 32b's, and then 16 times 1 is 16, so that's correct. And then I decided to move these from left to right, so b cubed is there. This goes there, it becomes negative. This goes there, it becomes negative, but I have one positive one there. It becomes minus 31. So unfortunately, that's a wrong problem, okay? So might be when I was doing it 25 years ago, I misprint something like that. Okay, but anyway, that was not a good question, sorry. Let me see if I can find you something else. No, because these problems immediately becomes a little bit hard. Okay, let me solve this problem for you. Okay, so let us go back here. I hope that these are not being recorded there. So number Now, this is a good question. Okay, so if I want to fix this equation, might be I can drop this last one, which is very silly then. So for example, if I take these two off, what will happen? It becomes 0 plus b, and then it might work. So I don't know, but I can fix it later. But you understand what is the essence. So this was a good example if it worked, because then you have to use GeoGebra. GeoGebra in the national exam in Math 4, when you have GeoGebra available, GeoGebra on its own cannot reach to this. So you have to do some calculations and reach to an equation which you can use GeoGebra to solve it. So that's a mixture of your work and GeoGebra work. Okay, but let me just try to give you another example. So where is my blue pen? So example. So if xy in base 7 is equal to yx in base 9, then what is x plus y? Okay? So how should we solve this problem?
You can write as first one you write as y plus 7x.
Yeah, so I told you, whenever you want to solve a problem in the basis, this type of problems that you need to find something or prove something, you need to expand. Yes? So that's very simple. So if I want you to expand this, what do you write?
7x.
Y plus
7x.
x times 7. Let me be a little bit careful here. Of course, in exam, if you just immediately write, that's correct. But I'm just trying to write it in a way that you understand. So this is the expansion. This is the expansion of this number. Equals to, what's the expansion of that number?
X plus
X plus
9.
y times 9 to power 1. This is claiming that these two numbers are equal. Of course, we can write it better. I can write it as 7x plus y on the left. I can write this as 9y plus x on the right. Okay? Then what do you think I will do now? So this is the translation of this one. So this is no longer a new lesson. This is just a very simple equation. But the problem is that there are two unknowns and one equation. Usually using one equation, you cannot find two unknowns. Okay? So what should I do? Let us simplify this a little bit. For example, I move x to the left, 7x minus x. I move y to the right, it becomes 9y minus y. This becomes 6x. This becomes 8y. I can simplify by 2, so it becomes 3x. It becomes 4y. Okay? So this is the simplified version. I cannot continue more than that. So then you have to have an argument. And be careful. This is hard to solve if you want to find all possible values. But here you don't want to find all possible values because x and y are integers. And for example, integers is smaller than 7. They cannot be bigger than 7, yes? Okay, either you have to try all possible scenarios to see which one works, but I can do a little bit better. For example, do you agree this is a multiple of 3? Okay, 4y is supposed to be a multiple of 3 because it is equal to a multiple of 3. Okay, so what can you conclude about y then? Y has to be a multiple of 3, yes? Because 4 is not a multiple of 3 and it doesn't contain any 3's in it. On the one hand, this expression should be a multiple of 3 because it is equal to a multiple of 3. On the other hand, 4 doesn't have even one factor of 3. So what can you conclude? Y should be a factor of 3. Yes? What are the factors of 3? What are the factors of 3? 0, the other one is 3, the other one is 6, the other one is 9, the other one is 12, but of course I cannot go here, yes? because I am working in base 7, so the maximum number available for me is 6. Okay? So I have 3 options. For which number? For y. Either y is 0, or y is 3, or y is 6. Okay, but y is 0 is not a good idea because it's a 2-digit number. So if y is 0, it's just 0, 0, it's also 0, 0. Okay? It works, of course, but when you write 2-digit number, you don't mean 0, 0, yes? So this is not the acceptable one. What about 3? Do you think 3 is acceptable? If I put 3 for y, what this gives me for x? If y is 3, x is 4. But what about this one? Do you think this will work? If y is what? 6, 4 times 6 is 24. So x becomes what? 8. Is 8 acceptable? No. So you see that this is also gone. So there is only one option left which works, and that is y3, x4. And then the question is asking you what is x plus y, yes? What's the answer? 7. Okay, so this was not possible. If I just give you this in Math 1C and I ask you to solve the equation, you cannot because there are infinitely many solutions there. Okay, so this is the nature of these kinds of equations in number theory. You might have more than one, you might have more unknowns than you have equations, but because these are supposed to be integers and you have some kind of arguments behind them, you can eliminate those that are not working, and there are only 1 or 2 or some few of them are left. All of them will be acceptable then. In this case, there's only one of them which is acceptable. Okay. Is that clear? Okay, so let me test one idea before we finish this lesson. Of course, when the lesson ends, do you know?